Hello again, everyone. Mr. Ritchie here. We are here to look at a couple of questions from your Balancing Chemical Word Equations worksheet. So this is a little bit more complex than what you were doing in the last section. Instead of having your formulas already done for you on this worksheet, what's given to you are word equations. So what you have to do is go through all 5 steps, from step 1, step 2, all the way through step 5, based on the notes that you took at the very beginning of the section. So this is a little bit more of a longer process, but hopefully by now you have enough practice with the balancing part that you can just kind of add this to the front end of it without too much difficulty. So I've selected just the first 2 questions from that worksheet. Now you already have the key, but you don't really have any sort of guidance for how to do it. So hopefully this video will help you guys in figuring this out. So if you're looking at your notes right now, which would be a good idea, you'll see that step 1 to turn a word equation like this into a balanced chemical equation with formulas is just to write out the symbols that you have. So you're just going to be identifying in your equation what the elements or ions are going to be. So I like to underline, you don't have to, but I'll just underline the important parts. Zinc, lead 2, that means lead plus 2, because we know that lead can be multiple different charges. Nitrate, that's an ion. And then zinc nitrate, and then there's our lead again. Okay. Another good skill to have is to be able to identify in your word equation what your symbols are going to be. And by symbols, I mean like those plus signs or the arrow for the yield sign. So what I'm going to do is, with a different color here, I'm going to notice words like and, produces, yield, anything like that. So I see an and, that means it's going to be a plus in my formula. Here's a react to form. This means I have an arrow. Okay, that's going to be the arrow that separates your products from the reactants. Okay, and then here's another and, that means plus. Once you've done that, you can start just writing out the symbols for these. So I'm going to start by writing zinc, which is Zn. There's my and, plus lead 2 nitrate. Lead is Pb. Nitrate on your ion sheet is an NO3. Reacts to form. Here's my arrow. Notice that I'm not worrying about any charges right now. I'm not worrying about the crisscrossing. That comes later. So I just like to write out all the symbols first, then I'll go through, put in the charges if needed, balance it out with the crisscross method, and then go through the rest of my steps. So I'm just going to move on to my products right now. Zinc and lead 2 nitrate react to form zinc nitrate. So write your zinc and my nitrate and lead. So and lead. Okay? At this point, you have step 1 complete. You've just written out all of the symbols. Now you can go through and you can put in your ionic charges and crisscross those if you need to make those compounds neutral. Okay? So going through this, I'm noticing that there's a couple of places where I have an element alone by itself. What that's implying is that the element is in its natural elemental form. That means that for zinc, for example, this would be like zinc metal. Okay, it exists on its own, it's perfectly stable, it's that shiny white metal that you always see, and this actually will not have any charge. Any elemental form of an element is not charged at all. Okay, so while zinc, when it bonds with something, will get a charge, okay, for example, a +2 charge. In this case, it's not an ionic compound, so we're actually not having any charge at all. You can actually skip that. So let's move over to lead nitrate. Now, lead is problematic. We know that lead can have multiple charges, but with our naming conventions, we know that transition metals like lead will always tell us what charge we're working with. Okay, so we know it's a lead +2. That's pretty helpful that they tell us in those names. Okay, nitrate This charge is on your printable sheet that had the periodic table of the ions. And when you look at the word nitrate, you'll see that it's NO3 and it's actually a -1. Hopefully you have that sheet out in front of you when you're doing this, so it kind of helps you a little bit. So move over. I'll put in all the charges first, then I'll crisscross later. This zinc on this problem is actually going to be a +2. I'll look at my sheet here. And then nitrate, like always, is a -1. Here's our lead. This is going to be alone by itself in its elemental form, no charge at all. Now go through and you crisscross. Okay, so this is the skill that we've done for a while. Our +2 and our -1 do not cancel at all. Okay, you're going to have leftover charge. So this tells me I need 2 nitrates to cancel out this lead. So that's why I bring the 2 down and I will apply that to my entire nitrate ion. That means that I need 2 nitrates to make this work. So you put that in parentheses. This 2 will apply to the entire nitrate ion. The 1 that was up here, this is applying to my lead, but as we know, we don't really ever need to write 1s. So that's why that doesn't really show up there. Okay? Same process over here. This zinc is also +2. So you're just going to erase your charges, bring that 2 down, apply that to the nitrate, and then the 1 applies to your zinc already. Okay? Step 2 is now complete. We have our charges crisscrossed. Step 3 is kind of a conditional step. It's not really going to be applied to this question, but you're going to be looking for the types of elements that will form diatomic molecules. And those elements are going to be hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Those are elements that don't exist exactly by themselves in nature. They will always bond up with another one. So, for example, you'll never have H by itself. It'll always be H2. That means diatomic, di meaning 2. Oxygen, same deal. Oxygen is always O2, excuse me. Fluorine, so on and so forth. Okay? As we're looking here, you might say that there is an oxygen here, which is one of our Hofbrinkels, as we say, but it's already bonded. It already has a buddy. It's not by itself. So the rule of thumb is that we never put that 2 there unless it's completely alone, not bonded to anything at the moment. So we actually don't need to do step 3 in this problem, so we can move on to step 4. Step 4, you guys should be pretty good at this one by now. This is your RP chart and balancing with your coefficients. So make your little RP chart, reactants and products. I've got zinc, lead, and I have nitrate ions participating. Remember, I'm keeping the nitrate together because it shows up on both sides. It doesn't split up into the oxygens and nitrogens. So leave that there. Tally them up. I've got 1 zinc on both sides. I've got 1 lead on both sides. And conveniently enough, I have 2 nitrates on both sides as well. 2 nitrates, 2 nitrates. This problem is already balanced. Okay? As long as you can get to this point where you have them set up, you will actually be fine. It is balanced as is.